Our next speaker is John Schiller from the National Institutes of Health, and he'll give a talk on patenting from the perspective of an NIH inventor. John.
Well, thanks. I have to start out by saying that this is the first time I've been at this meeting, and I have to comment that I've really been impressed with how thoughtful and articulate all the talks have been. So hopefully I can live up to the past performances here. So in about the next 10 minutes, I'm going to be telling you about the perspectives of an NIH employee. You've heard a lot so far about inventorship and corporate relationships from the point of view of academia, but I'm going to tell you these sort of things from the point of view of an NIH employee. And I don't want to overstress the point because in a lot of ways it's actually very similar, but there are some differences that I think hopefully you'll find a little bit interesting. And I have to talk from the point of view of the NIH because I basically spent my entire professional career at the NIH. My first 10 years I was doing basic research to try to understand how viruses cause cancer. And then roughly 20 years ago, my lab got involved in developing vaccines, particularly vaccines against HPV. And then this led us into a whole realm of tech transfer. And in the end, I'll tell you a little bit about it was basically the best of times and the worst of times for my first experience of trying to file a patent. And just to note, in addition to doing the normal type of tech transfer, I'm also been involved for almost 20 years now with the NCI's Technology Review Group, which evaluates intellectual property, patent applications, and patent prosecution for the entire NCI intramural research program. And more recently, I've been working with the Public Health Service Technology Transfer Policy Board, which involves tech transfer policy for not only the NIH, but also CDC and FDA. So the NIH scientists, we really actually have a relatively strong mandate for tech transfer. And the NIH in general, and the NCI specifically, really relies on patents as a primary form of IP protection for inventions and discoveries originating from scientists and laboratories. And we really realize that this is the main way that we're going to get our discoveries out to the public, because we very obviously realize that the NCI or the NIH doesn't manufacture drugs and it doesn't make devices. And so that the only way we're going to get it to people is to interact with companies. And it's actually interesting that it's actually in our mandate, and I copied this specifically, that all NIH scientists are required, it's a strong word, required to promptly report their inventions by completing and submitting employee invention reports to their institute technology officers before any public disclosure of the invention. Now, does this happen all the time? No, but this is supposedly required. And just to point out that we are covered actually by the same or different aspects of the Bayh-Dole and other types of legislation that was also put in place to regulate academia. And this, for instance, spells out the royalties that individual inventors in a government laboratory can and can't get. So just to give you an idea of what the workflow is at the NCI when an invention is made. So first of all, an invention report is filed with the Tech Transfer Center, and then it's evaluated by the Tech Transfer Center in conjunction with the Technology Review Group, which is a group of intramural scientists with experience in patenting and technology transfer. And then based upon that interaction, there's a recommendation to the scientific director as to whether or not we should move forward with filing an application or further prosecution of a previously filed application. Now, generally that recommendation is taken, but the inventor has every right to oppose that decision, and it's not particularly uncommon for the scientific director to actually overrule the committee and be convinced by that individual that they should move ahead. And then once the decision is made to move ahead, it's given to a contract law firm who then generates a provisional application, hopefully leading to an issued patent. And then during this process, we basically look for licensees and creators. Now, CRADAs are cooperative research and development agreements, and it's a very formalized process which allows government workers to work formally with a company. And from the point of view of the investigator, it can actually bring in financial resources and even sometimes personnel from the cooperating company into the laboratory. Now, from the point of view of the company, what they get is not only the NIH expertise, but they also get a right of first refusal for any intellectual property to get an exclusive license for that intellectual property that comes out of the CRADA, even if all of the inventors are NIH inventors. So that's a really relatively strong incentive to sign a CRADA. Now this just shows that, in this case, the NCI, we really are quite active at technology transfer. And this was given to me by some of the people in the technology transfer office. And what you can see is that in 2016 alone, the intramural program of just the NCI were issued 62 new patents. We signed 54 new CRADAs and have over 250 active CRADAs going and 132 new licensing agreements. So this is really quite a large undertaking. Now, it's important to point out that the NCI is not a company, and we're also not academia, okay? So most importantly, we do not patent technologies whose sole use is research tools. A classic example is it's been said that if we would have had PCR before our committee, we would say, no, it's a research tool, and we would never have patented it. But we can make research tools available either through material transfers agreements or for companies through commercial licenses agreements, but we won't restrict use by patenting. And importantly, the three major criteria of whether we're going to move forward for patenting is it in the public interest? Is it in the public health interest? Is it in the public health interest? That's the only criteria we have. Just royalties or making money off of the patents is not considered a reason for the NCI or the NIH to patent anything. And because, again, we have a public health interest in mind, the default is to give patents non-exclusively. So basically, any comer who wants it, who is competent, we will give them a license. And of course, companies hate this because they'd much rather have exclusive licenses. And occasionally, there will be exclusive licenses given in specific situations. For instance, there's only one competent company, only one company moving forward with the technology. But again, the reason for this is we believe it's in the public health interest to promote competition, not only during the development process, but hopefully in the marketplace. Although I have to tell you the story of the HPV vaccine that I was involved with. We did this, and we licensed both to Merck and GSK, and they came in within about $2 of each other in terms of the price of the vaccine. So, you know, in practicality, it doesn't always work out so well. So NIH employees can be named inventors, but they can't own the patents. The patents are owned by the federal government. Now, there are certain cases where when the government decides that it's not in their interest or they don't think it's worthwhile to patent, that we can waiver the government's right to the individual inventor. And this sometimes happens in situations where a government inventor decides they want to start their own company. But we also have in some cases, decided that it's not in the public health interest to do that, and it's better to dedicate to the public. And so examples of this might be if somebody invents a widely applicable research tool that may also have other commercial value in terms of a device or a pharmaceutical. But if it would hinder the broad dissemination of a research tool, we would actually decide against the inventor and not waive our right to patent. Now, one of the interesting things about being an NCI inventor is that we are totally cut out from the licensing negotiations, okay? And a matter of fact, even when the licensing negotiations are over, we don't know what the terms are. So I was involved in the patents for the HPV vaccine, which was licensed to Merck and GSK, and net sales of these vaccines are in the billions. And to this day, and this happened 20 years ago, I don't know what the terms of that agreement were. Okay, and it's thought that it's better to keep the inventors, the scientists, at arm's length from negotiations because it's considered an inherent conflict of interest. And we really run up against government ethic rules if we were involved in negotiations for licenses. So one of the things that's becoming more and more is that we really look at the NIH as being involved in international public health, as being part of our mandate. This really started back when Harold Zerhausen, when Harold Varmus was the NIH director back in the mid-1990s. And so because of this, we actually have been more and more now filing patents in emerging countries like Brazil and China and India, because we really believe that a lot of the next generation of pharmaceuticals are really going to be made in emerging countries. And certainly the area I'm most interested and involved in is vaccines, and this clearly is the case there. And so we're now starting to patent more there because we really believe that the next generation biopharmaceuticals is going to be produced at lower costs and be more widely distributed if we have the involvement of emerging manufacturers and allow them to have IP rights. So finally, let me just tell you a little bit about my first experience with patenting. So as I mentioned, I was initially a basic researcher, and we came up with the idea of developing a vaccine against HPVs, the HPVs that are associated with cervical and other cancers. And it turns out that this technology, which is virus-like particle technology, became the technology that was used for the vaccines. And we filed patents. And of course, this turned out to be a very valuable technology. And as many of you know, if any technology is really valuable, it's going to be disputed. And we actually ended up in a 10-year interference between us and 3 academic institutions, 2 in the United States and 1 in Australia. And if there was ever somebody who had a terrible notebook, it was the postdoc who did the work that actually led to this vaccine. And so having to try to defend his notebook in depositions when I had never filed patents before and didn't really realize what kind of notebooks you have to have was a real nightmare. But suffice it to say is what happened is that this interference was settled by cross-licensing. And not surprisingly, it wasn't settled until just before Merck was ready to market their vaccine. And so everybody scrambled, and what happened is there was cross-licensing of everything so that Merck and GSK had the freedom to operate. And as part of this negotiation, the NCI agreed to upgrade the Merck and GSK license to co-exclusive, which would then preclude anybody else from making the vaccine, at least in countries in which the original patents were licensed. And I failed to mention a little bit earlier that in the international aspect is that many of these patents, like for this, they weren't taken out in emerging countries. So India, China, Brazil can still make these vaccines. Now, one of the things that was a little disconcerting as an initial inventor is that the NIH agreed to abandon a bunch of our claims. And we thought we had the strongest scientific position. And to this day, I still think we had the strongest scientific position. But we couldn't reasonably suggest that we hold up the vaccine because public health interest demanded that we put out this vaccine. And so ultimately, being government workers and having to put public health first, we agreed to this. But of course, it was easy for us to agree to this because as inventors, we actually had no say whatsoever in the licensing process. So that's the story of of licensing at the NCI. And I think I did pretty well. So maybe if there's a question or so, take it.
Good afternoon, Dr. Schiller. Thank you for your very informative speech. Since you are talking about patenting as an NIH scientist, I had a question regarding FDA regulations. Because you mentioned that you also patent your products in emerging markets like other countries. And it does happen that when something is patented in the US, especially like a medical device, it happens very often that the medical device or the medical product is commercialized and is widely used in other countries for many years before it actually gets used in this country, due to mainly FDA regulations. So how in the NIH you deal with that problem when it arises? That you have a patent, you're marketing it in emerging countries, in other markets, but it is not yet marketable in the US because of FDA regulations, and whether in general you have any concern about FDA regulations, especially when it comes to medical devices.
Okay, I can't really comment on that because I don't work with the FDA. And just to make it clear, is the NCI or the NIH isn't marketing it in developing countries. We will license to manufacturers our IP to manufacturers in emerging countries, but that's entirely different from marketing. And what happens in the individual countries in terms of their national regulatory agencies, we really don't have any power to control that whatsoever. We're much more upstream in that. So I'm sorry, I can't answer your question any more than that. Sorry.
Okay. All right.
Yeah. Yeah. Sorry.
Thank you so much.
Yeah.